Fronius commercial solution saves 10,000 euros per year. Hello everyone, good day to today's lunchtime webinar. I want to kindly welcome you once again here at Fronius to our webinar series. Today I will show you a very impressive commercial reference in Austria, which is effectively saving 10,000 euros per year and therefore boosting your return of investment. Your Fronius team today consists of me. My name is Köhl Sandro. I'm from Team Trainings and Education from Fronius International in Upper Austria. And my colleague Helzer Hans, he is in Trainings Team 2, will support me today. So if you have any question during the webinar, please feel free to type it in and directly address it to Hans. Hans will give you immediate reply to your concerns regarding Fronius in general and our commercial solutions. And at the end of the webinar, he will join us live and point out the most interesting questions to all of us. So, what's on the agenda for today? First of all, I will give you a short introduction to the organic food retailer. That's the commercial application which I will show you, which is called Biohandel PICHLER, which is a company in Austria, and give you the insights of his PV system. We will make a kind of an analysis of the system. What are the biggest consumers within the systems? We will also have a look at the load profile of the company. And of course, I will point out the Fronius solution, which stands behind this huge success. I will show you some pictures of the Fronius solar web. So I did some screenshots and we will do an analysis together. And another part I want to point out is the e-mobility sector. Actually, the organic food retailer PICHLER is highly into EV. That means he has therefore also a charging solution, and I will present you his solution for his company. And the last point will be a quick summary and the prospect of the future. So what Mr. PICHLER is planning in the future with his PV system. But before we start, I actually have prepared a quick poll for you. So I want to address following question to you. Do you already have experience with Fronius commercial solutions? So I have here 4 answer possibilities for you. First one, yes, I have already done many projects with our current solutions with the Simo and the Echo. Yes, I have got some experience with it so far, but I'm more into residential PV. And fourth possibility is I'm here to just get an insight and an overview of Fronius and the reference. I see many of you are voting at the moment, so I will just wait a few seconds and then of course present you the results before we directly head into the webinar. Okay, so thank you very much for your voting. I will now close the poll and show you the results, of course. Thanks for that. And I will show you the results. So what is effectively the outcome? So 1/4 has already realized many projects with our Simos and Echos. 1/3 has got some experience with it. Very few of you are just installing commercial as an exception. And the other third is here to get an insight and overview over the Fronius solution, the reference. So thank you very much for your voting. I think this webinar includes valuable information for all of you, and let's directly jump into the topics. The best Fronius practical example, first of all, the short company presentation of this reference we are talking about today. So what is it about? It's an organic food retailer. That means it's located in Austria, in Upper Austria, in a city called Pershing. It's a family company which is operating since 2007. And here you see the CEO of the company, that's Mr. Günther Pichler. What is the company effectively doing, or how are they earning money? So Mr. Pichler is buying large quantities of fruit and vegetables from organic origin, and he packages this fruit and vegetables in consumer-friendly packets and then delivers it to all over Austria and also Europe. The key facts regarding its company side, so he has got 1,300 square meters of storage space. Nearly the half of it are cold storage space, and that's effectively a key fact why the PV system is so important. You see, nearly the half of the storage space has to be refrigerated. He has also 300 square meters of packing stations, offices, and hall. That's also an important part where a lot of electrical energy is consumed. Just think of all these packing station and packing processes. Therefore, a lot of energy is, of course, needed. And he has got an EV company fleet. So his current EV fleet consists of 4 cars. And therefore, you see it here in the picture. He has also a charging solution. And we will present you, of course, the best Fronius charging solutions therefore. The most important thing, of course, we are focusing on today is his very, very impressive PV system. You see, it's a classical rooftop installation with 100 kilowatt peaks installation on the roof. Situated in Austria, means in Central Europe. And it was initially commissioned in July of 2018 by a local Fronius system partner, which is called Mara Solar. On top, we have approximately 370 polycrystalline modules. That means these are the module type he's using, and the overall space which is needed is around, for the PV system is around about 600 square meters. The annual yield, according to the irradiation in Austria, is approximately 100,000 of kilowatt hours, and he has got a really, really high self-consumption rate of above 80%. That means 80% of the energy which is produced by the PV system on the roof is directly used by the company for all its cooling processes and packaging processes. His degree of self-sufficiency, that means the energy he is actually using directly from the PV and not buying from the grid, is of 40%, and CO2 savings also very important. Just think of the current situation, climate change and so on. He can really save 53 tons of CO2 and therefore also have make his contribution to a better world of green energy and renewable energy. So that was the system overview and the company presentation, what we are talking about. Now I will directly jump into the consumer analysis. That means that is always the first step if you plan your PV system. If you want to have the correct dimensioning, you have, of course, to look at the load situation and the biggest consumers within the system. Therefore, I did a process analysis. That means here key part is, of course, the company, and I've divided it in 4 sectors. The most important one is, of course, the cooling processes, because you have seen it at the beginning, nearly half of the company has to be refrigerated all the time to guarantee the freshness of the fruits and vegetables. There is also the office infrastructure, which is important, which has to consumes a lot of energy, and all the processing steps like packaging mechanisms and so on. And the 4th sector is the transport. So the EV fleet has also its energy consumption, and therefore is also a big consumer within the system. I have here now the load profile of the organic retail trade PICHLER. So actually that's the load profile of year 2017. So 1 year before the system was commissioned and actually in planning phase. So this load profiles you get from your power supply company. So you really have to look into detail when correctly dimensioning and correctly planning your PV system on this load profile. What can we read out of this load profile? So that's actually 1 year from January to December with each bars for each month. The green underlaid bars are the real energy daytime. That means that energy that is used during day. And if you see on first side, you can see that the green bars are always bigger than the blue bars. That means most of the energy is used during daytime, and that's effectively very, very good if you want to integrate a PV system, because of course the sun is shining during daytime, and if the most of the energy is used during daytime, that's a perfect match and integration of the PV system possible. The blue bars here are the real energy in nighttime, so this is very constant throughout the year. Just imagine you also have to refrigerate your fruit and vegetables during the nighttime, and therefore you also have a constant energy flow during nighttime. What we also can see on first sight, that during the summer months, so I would say between April and September, October, you have a higher energy consumption than during the winter months. That's also linked to the cooling processes, because in summertime you have a higher delta between ambient temperature and temperature within the company, and therefore more energy is needed to cool your space. And this is the base for dimensioning the PV system, and therefore the PV system was built up due to this load profile. So just to summarize this load profile, you see again, most of the energy is used daytime. I would say 25% are used nighttime, and the sum of the consumers is in total approximately 200,000 kilowatt hours. The average power of the company, that means is around about 65 kilowatts. And regarding reactive power, that means in kilowatt hours, that's also listed by the power supply company. That's effectively no problem. The company has got big machines, but he has not to pay for reactive power compensation. And how much energy could now be saved with the Fronius BEST solutions? So that is a real number. It's a very impressive number. So 10,000 euros annual savings can be reached by this PV system. And why is this possible? Yes, because of this very, very high self-consumption ratio. That means this is a really good example for commercial self-consumption and its high degree of self-sufficiency too of 40% means that you have a very low amortization durance of around about 5 to 6 years when the whole PV system is paid off. And you see it here, according to these numbers, that's a real business case and therefore very interesting, all due to this very, very high self-consumption ratio, which is reached by Mr. Pichler and his organic trade company. Good, that was some numbers and facts regarding the load profile. And now I want to present you the Fronius solution, which effectively stands behind this success. So the true success story is also really depending on the right inverter choice, of course. Just think on the overall cost structure. So the inverters are only 10% of the overall costs for a PV system, but they are responsible for 100% of the performance throughout the lifetime of the PV system. And therefore, it's very, very important to choose the right inverters to guarantee the success of your commercial PV installation. The system design of Mr. Pichler consists of 3 times the echoes. You see it here. These are the big ones. And 1 small Fronius Simo with 6 kilowatts, which is on the left side here. And additionally, a very key product is also the Fronius smart meter. So if you want to ensure full monitoring and full visualization in Fronius SolarWeb, you need to have for every installation, whether it's a residential or a commercial installation, you need this Fronius smart meter at the feeding point. So here the echoes in detail. So that's our current product for big applications. In this system designs, 3 times the Echo 27 is used. So it's really a cost optimized project inverter out of our Snap inverter series, the biggest one. It has got 1 MPP tracker, highest protection class IP66. So it's a very robust inverter with low weight. You see it around about 36 kilograms and a DC input voltage range of 580 to maximum of 1000 volts. So this are the big Snap inverters, which are in the systems, 3 pieces of them, and it is completed by 1 small Snap inverter. You see, this is the Simo with 6 kilowatts, which is equipped with the data manager card and which is doing all the data communication for this whole ring of inverters for the 4 inverters. This Simo has got 2 MPP trackers and also very high protection class of IP65. Again, very low weight inverter with 20 kilograms because it's effectively smaller, a smaller power class, and a very broad input voltage range from 150 to 1000 volts. So what is so special about the Snap inverter series? So if you know one of them, you know everyone. So nevertheless, if it's a Simo 6 or a Simo 10 or a Echo 27, the big one, every Snap inverter is handled the same way. So everything the same principle. And therefore, you're very, very flexible, of course, also for your commercial applications to choose the right inverter for your project. This one is equipped with the data manager. I told you they are connected via the so-called Fronius Solar Net Ring, and this data communication card is sending all the data to our Fronius SolarWeb portal. How does this effectively look like? So this system design you see here once again. Here are the 3 Echoes with 27 kilowatts AC output power and the small Simo with 6 kilowatts AC output power. They are interconnected via a Fronius solar net ring. So that means there is one master inverter, which is the small SIMO, which is also equipped with this data manager card and sending the information of all inverters to the World Wide Web and our Fronius Solar Web, where you as an installer or end customer can really have a look on it with every mobile device, if it's a smartwatch, a tablet, or a laptop. That's possible with every mobile device. How is it on the DC side? You see, Mr. Pichler always shows a little bit of over-dimensioning. That's of course possible with our inverters. For the Echos, it's up to 150%. On the DC side, you can realize over-dimensioning. And with the small inverters, you can realize over-dimensioning of up to 200%. Very key essential in the system is also the Fronius smart meter. So once again, we from Fronius recommend you really for every Fronius PV installation to install this primary smart meter directly at the feed-in point. You see here the grid in order to guarantee the full monitoring within the solar web and realize effectively energy management within your load section. Good, so much to the system design and the data communication. And now we directly go into the Fronius Solar Web portal. So what is the Solar Web portal? You see here at first sight, so I have done a screenshot of the start page of Mr. Pichler's system. Every system looks the same in SolarWeb. So at first sight, you see here on the left, that's the current power. That means you see here in the bubble chart here the PV generator, what comes down from the roof, what is currently produced. You see here the grid, that is effectively the grid consumption or the feed-in, that is demonstrated via the bubbles. They are dynamically, and here you see the loads which are supplied. In this case, you see it's directly supplied by all the PV power, and some energy is needed by the grid. So everything is regulated as from our inverter, and he can really realize simultaneous energy flows. In the middle, you can see the energy balance today. So every energy flows are recorded, and they are kind of demonstrated here. The production curves of the PV system. You can also look back in the past. That means you can really do advanced views and really do a lot of analysis work within the Fronius Solar Web portal. The earnings and the CO2 savings are here, which always remind you that it's a very, very good deal you made from economic perspective, but also from ecological perspective. And on the bottom, you see here the weather, which is included for your side of the PV system. Good. And then one example from the 3rd of March 2020, that means this year. You see that was, of course, a very, very good day for the PV system. So the PV system started to run at approximately 6 in the morning, then ramped up, perfect production curve. Around midday, you have the highest production, and then in the afternoon, it declines, of course, when the sun is disappearing. Good. What do we again see with the solar web? You directly see the power to the grid, which is here green underlaid, and consumed directly, which is, of course, the major part of the energy. That means that effective energy you see here, gray underlaid, is directly going into the company, into the cooling, into the packaging processes. Again, on this day, on this specific day, you have 84% of self-consumption. That means on an overall production of 500 kilowatt hours, 420 kilowatt hours are directly consumed, and the green energy is going to the grid. You can also make annual comparison. So I think that's also very interesting for customers. So you can do on a monthly base, on a daily base, and also on a yearly base. I have also made a screenshot today here. That's the most recent data I got from the 3 years. I told you it was initially commissioned in July of 2018. And in 2018, that means the first half year, we had this own consumption of above 80%, means 81%, which is directly consumed. 2019 also round about 80%. I think it was exactly 70%. And 2020 is currently running. But if you see again the bars, and if you compare it, we are definitely again on this right track and towards 80% of own consumption. So that means we are really on good track. So what's the best Fronius practical example? So I told you that's the sector electricity, but Mr. Pichler is also heading into sector integration. So that's also a very big topic here in the PV industry in general. So we do not want to target only the sector electrical energy. PV systems are going much more into heating applications, into mobility applications, and that's effectively also the way Mr. Pichler and his company is focusing on to include the e-mobility in his PV system. So his company fleet at the moment consists of 4 cars. So he has got one BMW, one e-Golf, and 2 Tesla types. You see here the front view of his company with 3 of his e-cars, EVs. How fast can you then charge on the company premises? So regarding EV charging, it's always very important to somehow define the maximum charge rate which is possible to reach. So I have pointed you out, this maximum charge rate is always depending on different factors which then define how fast you can charge your electrical vehicle. So on the one hand, it's very important the PV system size. That means in the case of the organic trade retailer Pichler, you have, of course, a very big PV system. So you therefore are not that limited regarding the maximum charge rate. Also, the capacity of the grid connection is very good to know, but also in a company premises, that's not that limiting factor, I would say, because the capacity is needed for other applications, and therefore an EV charging is not limited by the grid connection at the organic retailer Pichler. Also, the output power of the charging station, that's important, what charging solution you are choosing. And at last point, it's always the EV which is limiting the factor, okay, how fast can you charge your electrical vehicle. So the charging infrastructure of the company consists currently of 2 solutions. So on the one hand, he has got the KEBA solution. You see here on the picture. That's, I would say, in Europe, the most common one for public applications. It's very widely spread. And also he has integrated it in his company. That's the Type 2 plug. That's how you can charge, how you plug into your car. That means we always talk about 3-phase charging. That means now we talk about AC charging. That can be done 3-phase and 1-phase. That's also depending on the car type. So his wall boxes, that means his EV charging stations, are 3-phase connected, 32 amps and to a max of 22 kilowatts. That's also depending how fast you can charge or the maximum charge rate. So just an example, a BMW can charge to a max of 11 kilowatts AC charging, and an e-Golf can up to 7.2 kilowatts. That's also somehow depending on the model. A lot of Asian cars and Korean EVs can only charge one phase. So you're really depending here on the car manufacturer, and therefore look, of course, when installing such a charging solution, what car type you have. And the Tesla wallbox is also three-phase, 32 amps to a max of 22 kilowatts. And also within Tesla, it's depending not only on the type or model, it's also depending on the year it was manufactured. So the same model from 2016 can differentiate regarding charging rates for a model which was produced 2 years afterwards. So just take this into consideration if you're installing such a solution. How is PV energy now loaded into the fleet at company PICHLER? So at the moment, unfortunately, we have no intelligent charge control and no dynamic charge regulation. That means he doesn't load exactly after the PV surplus energy. There was no optimization until now. What is the reason for it? Of course, he has a very, very huge PV system, and the load distribution is, I would say, very equal. We saw the screenshot, and therefore he just doesn't exceed the maximum charging rate of his cars, which are mostly 7 kilowatts or 11 kilowatts for the Tesla, for example. And therefore, if he charges his EVs during lunch or somehow in the middle of the day, it doesn't exceed this maximum charging rates, but there was no optimization until now. But we from Fronius clearly recommend you to integrate such intelligent charge control. That means we have solutions, therefore we work together with partner. So last year at the Intersolar, we had an own wall where we presented this solution. That's the Hardy Bart EV charging solution. We can infinitely variable control the wall box. That means this energy management is done externally. That means you can perfectly couple it to our inverter and then use the PV surplus energy one-to-one for your EV charging solution. Just an example here, another day to get more insight on the practical side, what I want to demonstrate to you. That's EV charging, an average day, mid of last year, where we have had a self-consumption of around about 70%. That means we produced 600 kilowatt hours, more or less, and 430 kilowatt hours were consumed directly, and the other part, you see the green part here, was given to the grid, and therefore in Austria, due to the very low feed-in tariffs, it was given freely to the grid, and we somehow did not use it optimally. His charging solution now, if he wants to then decides, okay, I want to charge my EV now during the, I would say, mid of the day between 12 o'clock or 2 o'clock p.m. That means you effectively use your surplus power and you have this low charging capacity throughout the day. You see here on the picture, I have included here one 16 kilowatt hours of charging block. It means you charge 1 hour with 16 kV. That's the maximum his Tesla can charge. And you can shift this, this charging block more or less throughout the day. And you all the time use this surplus energy. Even with this high self-consumption, you can, doesn't matter what time of the day you, without intelligent charge control, you also have a very high self-consumption in this specific case. What does that mean if you feed in all this surplus energy? That means 193 kilowatt hours in kilometers. You can go with an example of 18 kilowatt hours per 100 kilometers. You can go approximately 1,100 kilometers per day. That means you are feeding in, but you can this amount charge, of course, in your EV company fleet and do an optimization of the system. How is it done with the intelligent charge control with Fronius? So I already told you this is one solution we are offering with FURHTER. So we have therefore key essential, of course, the smart meter again at the feed-in point and the Fronius inverter, which is therefore sending information to the EV charging box, the FURHTER solution. That means protocol is the solar API. We are fully compatible to third-party components and of course also different EV charging solutions. That's only one. We have very good experience with it. The smart meter you see here is connected via the Modbus RTU communication. It means that these 3 pins, D+, D-, and ground, you have the connection from the smart meter to the Fronius inverter. Yes, and once again, very interesting at this slide, maybe this picture, the dynamic PV surplus charging. So what am I talking about all the time? You see here, this is such a solution. We have again this production curve, and in the afternoon we decide to charge our EV, and we have this charging solution with this, which can support dynamic surplus power charging. And you see here, according one-to-one to the PV production, we follow the production curve, and in this period 100% of the produced energy is given to the EV, and therefore for this period of the day you have 100% on consumption, and that's effectively the way we are going throughout the day. Okay, that was I would say a very small excursion to the EV, which is also becoming more and more important in Europe and especially in Austria. Maybe a quick summary and prospect for the future. So once again, the very impressive numbers. So this is a real business case. So if a company looks at that with this very low amortization of 5 to 6 years, so a PV system pays off very fast in this case if you use most of the energy your own, and that's very Fronius best practice, Fronius best example with this 10,000 euros yearly energy savings, which makes it a very huge success. Of course, Mr. Pichler, I talked to him, wants to improve his system once again. So he is targeting continuous improvements. So he also wants to do something on the consumer side. So he wants to change all his lighting to LED lighting. It's also a way you can go, that you not only look on the energy production, you also look on the consumer side. He wants, of course, even he has got own consumption rates of above 80%. He wants to overreach this 80% with another sector integration. Just one picture here with the Ohm pilot. That's our, I would say, heating miracle, which you can generate hot water by use for hot water purposes. That would also be a possible, which is at the moment not done via the solar. And of course, talked about it, I would say, very detailed, this FURHTER charging solution. Okay, thank you very much. That was it so far concerning the reference. I hope I have told you or gave you some very interesting insights. So if you're looking for further information and webinars, just look on our YouTube channel. So there are a lot of how-to videos, and also our webinar recordings are uploaded a few days after the live session. Unfortunately, at the moment, we are also canceling a lot of trainings, but good message for you, we are focusing on virtual trainings. That means, like in our case, the webinars. So just stay updated, stay online. A lot of things are coming up. We are providing at least one webinar a day where you can really focus on your education and boost your knowledge with Fronius solutions, but also we have general webinars. Just look on the schedule. I think there is definitely included some things for you. We are also here for you all the time. We are working home office, of course, but customers are, the satisfaction is very, very important for us. So everything is running very good. So we are here for you all the time. That means we are definitely focusing on your concerns and here for you 24/7. Okay, good. Hans, I'm at the end now, but I promised you at the beginning that we will have a live joining of you with the most frequent questions. Hans, can you now hear us? Can you join us? Hello, Hans.
Yes, hello. Good afternoon. Yes, thank you for your questions. We have received quite a lot of questions, and I would like to point out two questions. First question was regarding a combination with batteries. Is there a possibility, or does it make sense to also add a battery in the system? Basically, I have to say we have at the moment only smaller inverters, hybrid inverters available in this range of 5 kilowatt. The next one from Fronius, which will come, is 10 kilowatt, a 10 kilowatt, the Sumo Gen inverter. They can handle up to 66 kilowatt hours battery in the future with BYD. So basically, in the beginning, we'll start with 22 kilowatt hours. And of course, the battery combination in this point would make no sense, because the battery system is just too expensive to get a good return of investment with the battery and a hybrid inverter. Basically, if you have a need for blackouts, because you have more often blackouts, then of course combination with battery would make sense, because then you are more independent and you can continue your business even in a blackout situation. This was the first question, and the second one was about the how would it look like in the Sunbelt country. Of course, we have a strong winter period in Austria, and in that moment we have not the highest cooling consumption. Therefore, in hot regions, we expect that you can double the efficiency and the doubling the power consumption, because you have also need in actually all over the year when you are in hot places on this planet. So therefore, I can expect you can double the numbers. The real savings are calculated with about 10 euro cents per kilowatt hour. So that would mean, of course, depending on the energy tariff, you would have then more or less as well as we did in our calculation. But I think in general, you can see as more you use your energy direct in a building, as better. And cooling, of course, is the best way. So everywhere, places where you have high cooling demand during the daytime, that's of course the ones which are really very beneficial, and the savings are here on the highest level. Okay, that was it for the first moment, but we will, I think we will continue with your answering your questions. Maybe Sandro, you can finish this presentation.
Yes, thank you very much, Hans, for these very interesting questions and your answers, of course. So just to finish the presentation, once again, thanks for your participation. Thanks for your time. We will stay now online for a few further minutes to respond to your questions. So if there are any open points, just type it in now. We will give you valuable answers, how it is possible for us. Thanks a lot. I wish you a pleasant afternoon. Thanks for tuning in. Stay fit, stay healthy, and I hope we see or hear us soon. Bye-bye.